Okay, so this is determining whether or not something is a function based given purely an equation. This is actually pretty straightforward. A lot of students get intimidated by this, but don't. There's actually two rules of thumb that you just need to pay attention to. One is if y is raised to some power, like this one here, y is raised to an exponent. If that occurs, then it is not a function. Oops, sorry, I'm about to lose my microphone here. There we go. Okay. Okay. If there is an inequality sign in the problem, it is not a function. Pretty much anything else is a function. Okay, so this one, our first one here, that one is a function. Okay, determining domain and range, however, is a little more complicated. For this one, you may be better suited, it may help you more to graph it if you have a graphing calculator. That may help you see it, and that way you can determine domain and range like you did for the problems previous to this one. If you don't have a graphing calculator or don't want to do it that way, that's fine. What you need to watch out for are exponents. So for our first two equations here, what you need to ask yourself is, okay, if I plug in any value for x, and you have an even exponent, if you remember, whenever you have an even exponent, whatever value you plug in, you're always going to get a positive value out. So, for example, if you do negative 2 squared, that's going to be negative 2 times negative 2, so that will give you positive 4. So even if you put negative values in for x, you're always going to get either 0 or a positive value for y. So for this one, x can be anything. X can be any value at all, right? It can be negative or positive. So the domain, I'm going to abbreviate that with a D in the interest of saving space. The domain is going to be negative infinity to positive infinity, but the range will always be just from 0, right? That's the smallest possible value y can be because y can't be negative. So it's going to go from 0. Oh, sorry, again, I'm just not quite singing up. I've got to turn in another ticket for these guys. Unfortunately, they thought they were done, but they're not. All right, so range goes from 0 to, oh, and that's going to be included. Sorry, it should be a closed bracket to positive infinity. All right, so that's the first one. This second one, it's kind of the reverse idea. In this case, y can be anything. It can be positive or negative, but you're only going to get positive values out for x. So the domain for this one, because y can be, again, say negative 3. Negative 3 raised to the 6th power, if you work that out in your calculator, you should get a positive number back out. But the x value is always going to be a positive one. So in this case, the domain, oh, again, that should be a square bracket, not a curved one, is going to be from 0 to infinity. But the range will be from negative infinity to positive infinity. So I know that's a little tricky, but again, if you're having trouble with this, I highly recommend graphing it on a graphing calculator, or there are graphing functions, programs out there online that will let you see the graphs too. So if this isn't making sense from a plug-in number standpoint, I highly recommend looking at the graph. Right. So then the last one, whenever you see something like this, if there's no exponent involved with an equality, you will always be able to plug in values for x and y that will make it less than 4. So really x or y could be anything. So whenever you see an inequality like this, as long as there's no exponents involved, the domain and range are always going to be negative infinity to infinity. So domain and range for this one. My infinity sign looked terrible. I apologize. Whoa, that one's not even close. That's supposed to be an infinity sign. I apologize. All right. Okay. Some other things that you need to watch out for, which I don't have written down on here, is if you're going to do this by hand, the other things you need to look out for are square roots, and if you have a possibility of dividing by 0. Oh, divide, they're supposed to be, not diving, divide. Alright. Hopefully you guys know what I'm trying to say here. Again, I gotta get the guys in here to fix the board one more time. Dividing by 0. Okay, so some examples from the book. If you look at number 35 or number 37, the number 35 is the square root. And remember, what you are not allowed to do is take the square root of a negative number. So you need to set the stuff that's underneath the radical to 0, solve for x, and that is the smallest possible value that x can be. So the domain will be everything to the right of whatever that value you find for x, because whatever is under that radical needs to be positive. For number 37, you need to ask yourself, okay, what would x have to be in order for the denominator to be 0? So it's much the same as when you're trying to solve for a square root. You set the denominator equal to 0, solve for x, and then that's what x cannot be. If people want to see an actual video of these problems, please let me know. I'd be happy to do that.